Welcome to this social science colloquium. Usually we're going to have the presentation in the chamber, so obviously the chamber is not available today. But I think this room is also very cozy. So my name is Dodo Xu. So I'm a assistant professor of sociology here at Hong Kong U. So I'm honored to introduce our speaker today, Professor Luo Ling or Ling Luo. Professor Luo is an associate professor of sociology and demography and associate director of the Center for Social Data and Analytics at Penn State University. And she has received generous funding from NIH, National Institutes of Health, and she studies how demographic processes and social forces influence health disparities and socioeconomic inequality and the distinct patterns and trends in social demographic and health outcomes among socio-demographic groups. And she has published in many leading journals, including ASR, AJS, Demography, Sociological Methods and Research, and Sociological Methodology. So without further ado, let's welcome Professor Luo.
Thank you, Dodo, for this lovely introduction. It's my great pleasure to present my recent research in this room. I would like to thank my co-authors, including my grad students, Jiahui Xu, my former advisor, Rob Warren, and Ken Land from Michigan. It's my great pleasure to work with them. And this research is supported by the National Institutes on Aging, and also support from the Population Research Institute and the Center for Social Data Analytics at Penn State. So we know that there is a vast literature on the association between education and health. We know that great education generally implies better health and a lower risk for a lot of health conditions. A prominent theoretical account for this education and health association is the fundamental cause theory. This theory states that greater education implies better health through a range of mechanisms, including more updated health knowledge, better behaviors, and also more social and economic resources. But much of the research in this line of research focuses on a person's own education. However, the life course and social network literature suggests that other family members' education, including spouse and also parents' education, matters. The reason is similar for how own education influences health. For example, better educated parents or spouses may be more aware of the negative consequences of risky behaviors such as smoking and heavy drinking. So they themselves were less likely to engage in those risky behaviors. As a result, they would reduce the exposure of their spouse or children to such behaviors. So that's one way that other family members' education may influence as a spillover effect of other family members' health. Even less studied is children's education, the influence of children's education on parents. This is probably because that children generally considered as the receiving end of caregiving, right? So we raise children, we spend a lot of money on them, they may or may not pay back. But we know that the direction of the caregiving may reverse in later life. At least in the United States, it was estimated that over 41% of adult children provide some care for their ailing parents at some point of their life. I know it's like a disappointing proportion. I'm hoping that 100%, but the reality is that about a half of the adult children provide some care for their ailing parents. So as the direction of caregiving reverses in later life, there is research, it's a small but emerging literature on this topic. Theoretically, this very interesting social foreground theory proposed by Wolf and his colleagues stipulates that adult children may provide health benefits, better educated adult children may provide health benefits through similar mechanisms. They may be more aware of those updated health knowledge or health techniques, MRI and so forth. And also they would provide a more psychological reassurance for their parents, and also more financial resources too. And there is scientists have begun to conduct empirical research in this field. There are a group of prominent scholars who started to look at the relationship between adult children's education and their parental health. So they found that at the individual level, adult children greater education provides more health benefits, meaning that parents whose children who are better educated will enjoy more health, like better health, compared to parents whose children were less educated. However, in the context of increasing education levels across generations in many societies, a central population level research question has remained unanswered or unclear. That is, what are the implications of this long-term trend toward increasing level of education attainment among younger generations imply for their parents? That is, this is a population level health disparity question. So there are several ways to think about whether the health inequality by education among parents would increase or decrease. If more children's education provide more health benefits to parents who are from a disadvantaged backgrounds, then the health disparity by education among parents will be reduced. In contrast, if the health benefits provided by better educated children are more pronounced for a more advantaged group, then we would expect that the health inequality would increase as the level of educational attainment increase across generations. So this question hasn't been examined in the literature. This is the question that we try to answer in today's presentation. So to answer this question, we use data, longitudinal data from the Health and Retirement Study from 1992 to 2018. So HRS is one of the longest and largest longitudinal aging study in the United States, focusing on the population age 15 or older. The reason why we didn't use, so they have newer data from 2020 waves and also 2022 waves. The reason why we didn't use it is because the children's information are not yet available in those newer waves. So when they release, well, actually it's not harmonized. So because you have to use the longitudinal version of it, but children's information are not available in those longitudinal files. But once they release the data, we will be updating the results using the newer waves. Because our focus on children's education, we exclude about 11%, it's a little over 1,000 HRS respondents from the data analysis, because when you don't have children, it's difficult to decide what the education level for those children. So we exclude those respondents from the data analysis. I will discuss the implication of this inclusion in the discussion section. We look at 5 health outcomes, including cognitive impairment, dementia, depression, activities of daily living, and self-reported health. Cognitive impairment and dementia were measured based on the telephone interview cognitive status scores, and then we use the Langa-Wire method to determine the status, a cognitive status, whether they are cognitive impaired or demented. And depression and daily limitations in activities of daily living and self-reported health are both, all of them are based on self-reported, whether they experience those limitations or experience dementia, depression, or general health. So by the way, the self-reported health are dichotomized too, is poor or fair health compared to good or excellent health. We have fairly large sample sizes. So in general, we have about over 125,000 observations from over 22,000 participants for depression, cognitive impairment, depression, and daily living activities, and also general health. The reason why we have fewer, smaller sample size for dementia is that dementia is a health condition that is pretty rare before age 65. So we have somewhat fewer observations for that particular outcome, mostly because we restrict the dementia analysis to respondents who age 65 or older. The key predictors that we consider here are parental or respondents' education. I like to be clear. So to facilitate a presentation and interpretation by parents, we refer to the HR respondents. So children are the children of the respondents, just to be clear. And we, to measure parents or respondents' education, we construct 3 levels of education based on years of schooling. For example, last time high school completion is corresponding to 0 to 11 years old, 11 years of schooling, and high school completion is approximately 12 to 15 years of schooling. College corresponds to 16 to 17 years of schooling. Because the reason why we construct this categorical educational level is that we look at the educational inequality, so which you will see later a graph showing the disparities, that is the difference in probability of experiencing those conditions by comparing the last educated group to the high school completion group and the college educated group compared to the high school completion group. For children's education, we have 2 sets of measures. The first one is last time high school completion compared to high school or more. The second set of measures is last time college compared to the college. The reason we have somewhat different setup for children's measure is that our goal is to assess how increasing children's education may influence educational inequality in health for parents. So this set of measure would give us estimates about how much health inequality can be reduced or increased by setting all children to have college education. And this set of children's education measure will give us estimates how much reduction in educational inequality in health by increasing, by having or forcing all students to complete college, for example, coming to Hong Kong University. And also one complication that you may notice is that associated with children's education is that about over 92% of our respondents have reported more than one child. By child, we mean either biological child, adopted child, or stepchild. So more than 92% of them reported more than one child. So the question is which child to pick. So we, in the main analysis that you will see, we use the child's education based on the least educated children among all. The reason is that, or this strategy would allow us to avoid this potential ceiling effect of using maximum or highest educated children, because for the HRS respondents, over 98% of the respondents whose most educated children completed high school education. So we use the lowest educated children as the measure of children's education in the main analysis. However, in additional analysis, sensitivity analysis, we consider 3 more alternative measures, including, the most educated children, or we use the average years of schooling, or the average of those education levels of all children. We also consider another way, that is we randomly pick. So if a HRS parents reported more than one child, we just randomly pick one of them. So we don't care it's the least educated or best educated, most educated children, just random pick one. So that's the third alternative measures. Interestingly, all the results based on different ways of measuring children's education give us very similar results. Although I do want to note that I can talk more about that during the discussion. That is, if you use the least educated children's education, the reduction is the most prominent, although there are no like statistically significant difference depending on which child's education measures you're using. But at least qualitatively, you can see that it's the least educated children that provides the most health inequality reduction. I'll talk more about that using a figure. Any questions so far? Clarification questions? All right. So as I mentioned, scientists have already begun to examine the health and children's education relationship, but most of the time those researchers use the standard regression models to understand how children's education influence parental health. But the dilemma here is that, as you can see using this graph, children's education completes after parental education. So children's education can be, because this is our treatment variable. That's our like primary variable that we're focusing on. Parental, again, by parents, I mean HIS respondents. So this is our treatment variable. Usually children's education completes after parents complete their own education. So for example, they usually complete their education when their parents are age 13 or until 15. So this is we consider this as a post-treatment variable. When you include both a treatment variable and a post-treatment variable in the standard regression model, the regression coefficient would not give us an accurate estimate of what we intend to estimate, that is the parental educational inequality in health. So I'm not saying that they are doing the wrong thing, but I think the goals are very different, because in those prior research, they primarily focus on at the individual level, what is the association, whether there is any association between children's education and the parents' health. But here, we need to include both these variables in the model, because we're interested in, first of all, what are the accurate estimates of parental educational inequality by education, and also how increasing children's education would influence this health inequality by education among parents. So we propose to use a different framework to understand how increasing education for children may influence parents' educational inequality in health. But before talking about the methods, I would like to be very clear about what kind of substantive question or substantive quantities we're trying to estimate, and then define the estimates. So like I said, our primary goal, our first research objective, focus on a better measure or a more accurate estimate of the parental educational inequality in health. We need to control for the pre-education covariates, like what I mentioned here, including those parents' childhood health conditions, their parents' financial situation, and so forth, in order to have a better estimate of the parental health inequality. So for that one, we label this quantity as average treatment effect of parental education. Our second goal is to assess how increasing children's education would reduce or increase parental health inequality. So to estimate this quantity, we define this estimate called controlled direct effect, or CDE. So in the literature, I'm still new, I'm learning this literature too, in the causal mediation analysis, this quantity controlled direct effect provides assessment of how changing the mediator, which is the children's education in our analysis, in hypothetical scenarios by setting different values to the mediator. That is like thinking about how, in a hypothetical scenario where all children go to college, in a hypothetical scenario where all children at least complete high school. So I think this quantity is very useful for answer our research question, even though it's less used in empirical research for education and health. So to estimate these two quantities, we follow a two-step weighted marginal structural models. This approach consists of two steps. The first one to construct weights based on pre-education covariates for parents. This includes their sex, race, birth cohorts, their parents' education, in what region they're growing up, and also some childhood health and socioeconomic conditions. And the next step is to use those weights, constructing step one, to weight in multi-level models using parental level weights. So this approach gives us a better estimate of the educational inequality in health among parents. Note that we don't control for children's education or children's pre-education variables, because all these are post-treatment or post-parent education variables. To estimate how parental inequality, health inequality change as a function of children's education, we again follow the follow two-step procedure. The first one is to construct weights based on child-level controls. So we include controls such as sex, like we know that boys, at least for children of the HR respondents, boys are more likely to complete higher education compared to girls. And also birth cohorts, we know that education levels increase by birth cohorts, and also parents' education, parental marital status, whether they divorced or widowed or something like that, and also parental occupation and parental financial situation. These variables, parental marital status, occupation, and financial situations, are they have higher level of missingness for all those, like less than 2%. We have missing data, but for the last three, we have higher percentage of missingness. About 13% of the children in their HR respondents reported missing information. So we use multiple imputation, and also we compare the data with and without imputation, so they are very similar. And the next step is to use a combined weights based on both the parent and the child level weights to weight these multi-level marginal structural models. Just note that to estimate the CDE, the control directive factor, we need to use both parent and the child level weights. So this approach avoids this poultry. So remember that we need to include both parents and children's education. This marginal structural approach allows us to avoid this post-treatment bias. The reason why we need to use multi-level, because HRS data are longitudinal, so we know that observations within individuals are nested or correlated. So the multi-level part accounts for the correlation among observations within individual. So here are the results. I know that we are we're looking at 5 outcomes. Here we will use cognitive impairment and dementia as the first 2 examples. I will go over the results for the other 3 health outcomes in next slide. So the y-axis represents the difference in predicted probability in experiencing a health condition compared to the high school complete group of parents. So the yellow bars indicate higher probability of experiencing cognitive impairment of the least educated parent group compared to the high school completion parent group. The blue bars, which usually have negative values, indicate lower likelihood or lower predicted probability of experiencing cognitive impairment for the college-educated group of parents compared to the high school completion parent group. So, and then there are 3 sets of results for each outcome. The leftmost column represents the health inequality by education groups for parents. So this is our ATE estimate. That is the education health inequality by education group. So consistent with the literature, we see that greater education implies better health, less education implies more negative health. And these 2 columns are the 2 sets of control direct effects of setting children's education at different levels. For example, this middle column represents the control direct effects by setting children's education to 12 years or more, meaning that all least educated children for all respondents will complete high school education. So no children have no less than high school education. And this column represents the hypothetical scenario of educational inequality in health if we force all the least educated children to go to college. So as you can see, if we set all children to have high school education, then we will see about 6.7 percentage point reduction, which corresponds to about 34% fewer or like smaller health disparities compared to the ATE. Or this equivalent to about 1.8 percentage points reduction in parents' experience for the lowest, like least educated parents who would experience dementia, which corresponds to about 27% reduction of the health disparity. If you force all children to go to college, and then we would see a small further reduction in educational inequality for the least educated parents, which corresponds to about 8.2 percentage points or 14.2% reduction for this least educated group compared to the high school completion parents group. And for dementia, they would experience about 2.5 percentage point lower probability of experiencing dementia. One thing to notice is that for all those college-educated parents, the influence of increasing children's education do not seem to play a big role, meaning that they're about the same. So their health advantages were not affected or changed much by increasing children's education. Do you have a question?
Is that net of income and everything? This is a net effect?
That's a good question. It's not. The reason is income is a post-education variable. So we are looking at educational inequality in health. So I think that's the methodological reason, but substantively we focus more on the upstream effect of education, because usually education precedes income or occupation. That would, maybe another research paper or question to answer, like, what's the direct effect of education on health, or what's the indirect effect of.
Did you say this is a total effect?
Yeah, it's the overall effect. So I would say this is an overall effect. It doesn't mean, it doesn't say much about what are the mechanisms. So more part of it are translated or conveyed through income or occupation or other. I think we'll have a discussion at lunch about like why people, well, that's my question. I ask why the stratification scholars in this room don't focus on education, but more about income and occupation. But I think education has a special role, especially in the U.S. context, because that speaks a lot about your health behaviors and social network too. Thank you for the question. All right. So the health disparity reduction effects are also evident in all other outcomes, even though we use the same scale to just facilitate comparison. This is for the limitation in activities and the likelihood or predicted probability for experiencing depression and self-reported health. For example, if all the least educated children have high school completion, we would see the health disparity between the less than high school group to high school be reduced by 3.2% or percentage points, or 13.7% reduction. About the same for depression and self-reported health. If all of them have highest education, that is college completion, we see a somewhat further reduction ranging from 13.7% to 14.3% in the activity limitation, depression, and self-reported health. Again, as we have seen for cognitive impairment or dementia, the health advantage enjoyed by the most educated parents group do not change too much, at least statistically. So the conclusion is pretty straightforward. That is, increasing children's education reduces educational inequality in health. What are the potential mechanisms that contribute to this reduction? In additional analysis, we show that there are two potential mechanisms. One is effect heterogeneity, the other is compositional change. By effect heterogeneity, we mean that the health benefits are more pronounced. Health benefits of increasing children's education are more pronounced for the disadvantaged parents group, meaning that the better educated parents themselves are pretty well protected by their own education. So increasing education, children's education, don't change much of their own health benefits. So at the individual level, there's differential health return by education, by children's education. So at the population level, we see a reduction in health inequality by education. The second potential mechanism related to the intergenerational, it's an intergenerational process called intergenerational transmission of education advantage or disadvantage. This sociological notion refers to an intergenerational process in which children born to highly educated parents are more likely to obtain higher levels of education. So when you increase children's education at the population level, which is actually is equivalent to increasing, kind of interrupting this intergenerational process, so that a larger scale or like larger proportion of children born to disadvantaged backgrounds benefit more. So meaning that the proportion of the more disadvantaged children will benefit more when you increase the children's education level at the population level. So this is the compositional mechanism to which that could result from increasing education, children's education, to reduce health inequality. Does it make sense? So this research also has theoretical implications for studying the education-health relationship. So usually we think about education as health resources for a person at an individual level. This research shows that education can be considered as a cross-generation resources. These resources can flow upstream, downstream from parent to children, but also can flow from upstream from children to parents, especially in later life health. The second implication is that usually we talk about modifiable factor for health, for improving health and addressing health inequality. Usually education is considered as an early life modifiable factor, but this research shows that even though we can't change much about parents' education, right? Because they already passed that age, past that life course window. But when you think about children who complete education when their parents are about age 13, 14, so that actually extends the life course window in which education can be considered as a modifiable factor. So it's not only an early life factor, but also a midlife midlife modifiable factor for improving health and addressing health inequality. Of course, there are limitations in this research, because we focus on the overall effect of education on health, or the overall effect of children's education on parental health. So in our analysis we treat race, gender, and birth cohorts as covariates. So we don't specifically look at how much those educational benefits differ by between whites, non-whites, or men and women, or birth cohorts. We did some rough preliminary analysis, subsample analysis. So in subsample analysis we have fewer observations, but at least based on the HRS sample, we see that the results are largely consistent across race and ethnicity, and also between men and women, and between the baby boomer cohorts and the later cohorts. The second limitation is, what about people without children, right? We talk about children's education for their parents. We exclude non-parents from our analysis. We know that from the demographic literature that also consisted in our own analysis that non-parents tend to have fewer years of education, and they tend to have worse socioeconomic status, and also they have higher prevalence of experiencing those health conditions. So this research does not provide direct evidence about how increasing children's education would influence non-parents' health. But I would like to point out that recent research in social network literature shows that people who don't have children may benefit from children of other peoples, especially from extended families. For example, my colleagues JD and Ashton, they have shown that at sometimes nurse and nephews are actually provide a lot of social support for the aging uncles and aunts. So treat your niece and nephews well. They may provide some valuable resources when we are older. Again, the take-home message is very straightforward. So we need to invest in children's education. I think this is going without saying in the Asian context, but not necessarily outside of our Asian society where the focus may not be on children. But also I want to emphasize that you see that increasing children's education do not eliminate health disparities completely, right? The health inequality by education remains even if we increase children's education to college completion. That's pretty dramatic. So just take the conclusion with a grain of salt. That is, you need to invest your own education and health too. And that's probably the primary focus in our life. I'd like to take a few more minutes to talk about my research agenda, what is going on, and because I'm recruiting 3 postdocs, if you're interested, I'll say more about that. So this project is just one of several research projects that's looking at how multi-generational process influence health. For example, this is one recent article that I published with Wei Lai, who is in the audience, in a Journal of Health and Social Behaviors. We again use a 2-generation approach. We show that the health benefits of college education are remarkably similar across socio-economic backgrounds. This addresses a very interesting sociological debates about the return of college education. We know that there are ongoing debates about how college education imply for income benefits across socioeconomic groups. Here we show that the health benefit of college education are very similar across socioeconomic groups. Doesn't matter you are coming from a disadvantaged background or advantaged background. As long as you go to college, the health benefits are very similar. In another project, I'm developing a sandwich generation or adjacent generation approach. So for those, you're pretty young, but for a few who has some gray hair, we know that we're familiar with the midlife crisis, or not crisis, but mid-age life that is filled with care obligations for caring for your aging parents and also your growing children. So we're the sandwich generation. I'm developing this sandwich generation approach to look at how the experiences and socioeconomic resources from these 2 adjacent generations compound or interact to influence the sandwich generation's health. And relatedly, because in the United States, we know that the intergenerational process are very much different by race and ethnicity groups. For example, non-Hispanic Black people experience higher rates of downward mobility. So I believe that the sandwich generation approach will be informative for understanding how health disparities among race and ethnicity groups are generated from, because usually we only focus on the respondents' race and ethnicity, but I'm believing that, things are not happening in a vacuum. You are living in a multi-generational context, and how adjacent generations influence your own health can be a very interesting topic. Besides my US-based research, I also expanding my research to understand, non-US context. For example, my students and I are looking at harmonized agent data across the globe. For example, from China, from Korea, Japan, and European countries, to understand the role of educational expansion as well as socioeconomic inequality in influencing trends in various health outcomes, including dementia and depression and so forth. Besides these substantive topics, I'm also very interested in methodological work. For example, I recently proposed a new age period and cohort interaction model that allow us to look at, to identify unique contributions of different cohort membership, different ages and time periods, contribute to the observed trends in, all kinds of health conditions and diseases. I would like to emphasize that, demographers are often said we are atheoretical, but I do think the benefit, the advantage of this APC interaction model is that it's motivated by the demographic notion about under what conditions cohort affects us, how different cohorts differentiate from each other. So that's the theoretical motivation, and also therefore it does not have the typical identification problem in the typical APC models. But there are a lot to think about. So I do think for some of you who may know my prior work on age period cohort debates, my position is that, the birth cohorts, the merit of birth cohorts are beyond statistical models. We need to think about what would be the best way to understand cohort effects, what would be the best way to understand how social events interact with different ages to produce this lifelong or lasting effects of those people's experiences. And also, based on my recent work on two-generation mobility, that's published in American Journal of American Sociological Review, I'm looking at three-generation mobility patterns and the implication of those patterns for well-being and health. So these ambitious research agenda cannot be accomplished by myself alone. So I'm fortunate to have resources to recruit three postdoc trainees who is interested in pursuing those exciting projects. Or you have students who are interested in this, line of research. Please feel free to email me. This is my email address. So yeah, thank you for your time and attention. I look forward to your questions.